Hello everyone, welcome to another edition of the Qorent-Xperts podcast. My name is Osagie, your host, and I'm super delighted to have you on this episode. Today with me, I have the amazing Osagie Ehigiato, Engineering Manager at Prime On-Site Hubs, and we're going to be discussing the topic, designing for scalability, building system scalability from the ground up. And as I always say, at Core, we hire the top 1% of the 1%. So you are assured of getting subject matter expertise on any topic that we discuss here today. Hi, Osagie.
Hello, Tulu.
So I'm super delighted to have you. Thank you for agreeing to do this.
Yeah, I'm excited to be here. Thank you very much.
Awesome. So I'm going to introduce you properly. I like to give a little bit of gang welcome for my guests.
Okay. Let's hear that.
So awesome. I'm going to read Osagie's bio shortly, so that we have a bit of context. Osagie has been in engineering management here at Core for about 2 years, and prior to that, he has been in various engineering leadership positions for more than 5 years. Through his career progression, he has worked with various teams on different kinds of applications, from health to line payment and bill platforms and education systems, as well as fintech products. He has led teams successfully that have scaled applications and related components. The experience so far, in Osagie's word, has been fun, challenging, and has come with a whole lot of learning and impact, as well as the experience and opportunity to drive goals, manage people, train, mentor, and also provide architectural solutions to software projects. Everyone, welcome with me the amazing Osagie. Yay! Thank you for taking a bow. So awesome. Great to have you on this episode of the podcast. Mind you know, this is the very first video format of this podcast. So you're the first person that is watching this portion or this aspect of the podcast, and we're super delighted about that. So Osagie, I'm basically going to narrow down into why we're here today. We're discussing designing for scalability and just general best practices for building scalable systems. As we all know, we have different products out there. It's not just enough to have a great idea that you can ship. It's also important to be able to scale that product or idea sustainably over time. So let's just get right into it, starting from defining key terms. How would you define scalability in the context of system design?
Okay. We are talking about system design and scalability. They are intertwined.
Okay.
So because it's at the point where you are designing your system that you factor in scalability.
Okay.
So in plain terms, or in more simpler terms, scalability is the ability of system to be able to take on more workload or increasing workload without even compromising whether it's integrity, user experience, or performance. One thing with good systems that are well designed, is that they are adaptive to changes, whether changes in increased data, users, or increased workload, right?
Okay.
So for scalable systems are able to sort of anticipate future changes, right? With minimal change in the applications themselves, because you have basically built them to be extensible, right? And to be able to scale. Now, there are two main approaches to scaling systems. Two broad approaches, or two major approaches to scaling systems. It's either you are doing vertical or horizontal scale.
Okay.
There's a whole lot involved, whether you are doing vertical or horizontal. So, but vertical scaling is also referred to as scaling up. That means for a particular server, you are just increasing the resource, either the memory, the RAM, or any other available resource. You just increase it. So it's scaling up.
Okay.
It's just like for a road, maybe a highway, for you to accommodate more cars, you are expanding that highway, right?
Okay.
But for the horizontal scaling or scaling out, it's when you are adding more server, more resource, that is adding more servers, not just adding a resource to the server. So here you are adding more servers or more nodes. So you can look at it like, okay, for you to increase, for you to accommodate increased traffic on a lane, let's get 3 more lanes. Let's get four more lanes. That's like scaling out. So those are the 2 major approaches.
Awesome.
To scalability.
Wow.
Yeah.
Awesome. I told you guys that we are in for an insightful conversation. We can say that this is just the first question. I'm already getting loads of value. So I hear you from what you say. We can either scale up vertically or scale sideways horizontally, and basically the concept of scalability is, in my mind, in layman terms, is like being expandable, like building to be able to accommodate more, basically like building from the start with that mindset of, okay, in the future I might need to like expand, get more workload and the likes. Awesome. So now let's just zero in on you a little bit. So what inspired you to focus on this concept of scalability?
Okay, one simple word: need.
Yes.
The need to scale. So in my early career, I have encountered systems that had scalability issues. And throughout my career, I've worked in teams and be part of a team, and I've seen platforms that has scalability issue. And it has been a major concern for me. So with this in mind, I had to focus on scalability, delve more into scalability, and it has been awesome.
So like you rightly said, you've spoken to how the reason why you went into scalability as an engineer is the need for it. So how can you like just zero in more on why scalability is actually crucial for modern day applications today?
Okay, yeah. For modern day application, scalability is a key factor and very crucial. So some of the reasons why is, 1, unpredictable growth. You see, there could be a surge overnight in user demand or popularity of an application. And then there's high usage, you have data, you have more requests, and it's a truly global world, right?
True.
So some of those things could just happen overnight, and you should be prepared. We have seen a lot of examples of that, and we have heard much about that. For instance, ChatGPT, when I brought it out, at the earliest stages, there was a time where they had scalability issue. Why? Because when they brought it out overnight, it became very popular, and people were wanting to try it out. Oh, this new thing, let's try it out. So there was overnight surge. So they had some scalability issue which they had to quickly sort out. So there's unpredictable growth out there, which could happen at any moment. So another reason is the issue of data-driven design, data-driven applications. Right. So a lot of modern applications are data-driven. That is, they work with a lot of data, process a lot of data, store a lot of data. And for a lot of applications, the data grow over time. You need to be able to build applications that can accommodate, process, and store data as it grows over time, or as it grows overnight too, right? So there's this user, that is the demand of user, ever evolving user demands, right? So that's another key factor. User demand could change from time to time and could change often, and users expect that even when their demand change, which could lead to changes in your design or changes in some features and the rest, right? They expect that those changes will not affect how the system operates.
Yeah, true.
Right. So depend on where you operate, or the scope of your application, or the reach, or the locations where they are. Sometimes there are also some users that have special demand, like for instance, government controls, right? So a government in a region may say, okay, for this particular app, we need this feature in our region, or our users should be able to do X, Y, Z, whether it's coming from your normal user, from regulatory entities. Yes, let me call them regulatory entities, right? So the need to evolve, the need for your app to evolve based on user need is also there in today's modern world application. Another thing is competitiveness, competition. You see, when your app is not scalable, when there are scalability issues, your users may start thinking of, oh, this app is not okay. Can we look for a competition? So with that, you may lose market. When you don't design scalable app, you may lose your market. Yes, these are some of the reasons why it is very, very important.
Okay, awesome. So in my mind, I'm picturing a situation where, so if would you say it's a scalability problem for maybe a app that I opened before and was working perfect, I was working fine, just basically shuts down? Yeah, I know it could be related to maybe other factors, but could scalability be one of those factors?
Scalability generally comes in. When we talk about scalability, it's something that affects increase in users, in usage, in data. So without increase in usage in some form, or increase in data, or increase in processes, and your app have issue, then it's not a scalability issue. It could be a performance issue.
Okay. Right. Thank you for spelling that out. Thank you so much for spelling that out. Okay, so I'm going to go to my next question. We've established the importance of scalability for modern day applications. So what are the key factors to consider when, as like an engineer, what are the key factors to consider when you are designing for scalability for products?
Okay. When you consider building scalable systems, there are several factors that come into play.
Okay.
So I'm just going to list a few, right? So the architectural factors, development factors, design, and other things, right? Okay. So for the architectural factor, one of the first things you need to do is to break your system into modules. Let them be modular, something like microservices, to focus on specific business areas.
Okay.
So what this will also help to achieve is that when you need to scale, or maybe when you need to scale a particular, you can scale a particular business area, right? When there's need to scale that particular part.
Okay.
Right. So another thing is choosing the right tools. Choosing the right tools. So there are tools that can be used for various stuffs.
Okay.
Right. Depending on the application that you are building and the problem and your problem domain, right? There are right tools or best tools that fit into that condition or into that problem domain that you can use. So you should know when to use caching, right, where necessary.
Okay.
Right. You should know where to use SQL databases, NoSQL databases. You should know when to use certain programming languages where they have strengths. For instance, when you look at some big systems out there, right, some of the big systems in the world, Facebook, Uber, and the rest, they don't even use one programming language. They don't use one database because they understand that, okay, for this type of data we need to store, this is the type of database we need to use that's most efficient.
Okay.
For this particular programming task or challenge, this is the programming language that best fits. You see, some parts of their components, they may use C or C++. Some other components, they may use something else, like Java, which is a higher level programming language than C.
Okay.
C, for instance. So there are things that those things solve appropriately. Okay. So it's good to understand those tools and where their strength is, and then also use the tools that have proven track records in solving certain things. Right.
Okay.
So some of those considerations will help. And also, when designing system, design applications that are stateless.
Okay.
So when I say stateless, what do I mean exactly? So when you talk about stateless applications, they are applications that do not depend on data on a particular machine.
Okay.
Such that when you want to scale, maybe you want to do horizontal scaling, and you are scaling out and adding more server, adding more nodes, they don't depend on data on just a particular server, right? So that there is no issue of data integrity, right? So it's also very important. Then also know when to use things like caching. So also implement things like monitoring, performance monitoring, alerts, and the rest, so that you can always look at your system to always improve it where there needs to be improvement. So those are very key factors.
Amazing. I'm telling you guys, by the time I'm done with some of this podcast episode, I will already become a learned engineer. I'm just telling you, with the amount of stuff that gets dished out on these episodes of the podcast. So please always feel free to share with as many people in your network as well. Thank you so much for that, Osagie. So I just want to clarify something you said about the stateless building on the stateless system and stateless applications.
Yes.
Can that also be used in reference to building on the cloud? Or that's a different thing entirely?
You can build stateless applications on the cloud.
On the cloud.
Exactly.
Okay. So building on the cloud is not we trying to avoid building on a machine. I just want to clarify that for as many people like me that are not engineering gurus. So you need to break some things down. So you are saying that the stateless conversation is totally different from building on the cloud?
Not totally different, but it's a different thing. Okay. For instance, building on the cloud, you are just taking your application to maybe a cloud service provider and put it on their machine. Although for the cloud service provider, they offer some further services that can help your scalability, but you can still build on the cloud and you do not follow the right principles, and then you will still have scalability issues.
Okay.
Then your data will still be on. You can build on the cloud and even on the cloud, you can also scale to different servers, different nodes. So your application should not, how do I put it? Should not depend on data on a particular machine, on a particular node, on a particular server. Because even on the cloud, you can scale.
Okay.
Yes.
Okay. I get you now.
Yeah.
Okay, awesome. So I'm going to go to my next question. This has been an insightful conversation. Can you share some of the best practices? Because you rightly mentioned that you can build on the cloud but not follow the right principles. So what are some of the best practices that you can state for us on the podcast in terms of building for scalability?
Okay. I think I've mentioned some of them, by the way. So, but one of the things you should consider when you are building for scalability is having the end goal in mind. What do I mean? You are building an app. What is your audience? Who are your audience? Right? What's the number of users that you are envisaging on that app?
Okay.
Is it for the public? Is it for particular institutions?
Okay.
That the number of users may not be much? What's the data requirement? So how do you scale properly on the environments where you are building or for the users that you are building for? So some of the end goals should be on your mind and should be in consideration when building.
Okay.
So that's part of it. So as I've also mentioned earlier, you follow a good architectural patterns like microservices, building modular applications, such that you can focus each service on a particular business need and can scale it independent of others. If there is growth in that particular area, you can scale it independently.
Okay.
Then adopt certain practices on your code, like loose coupling, right? Such that a change in one part of your code does not necessarily affect the other. It's not intertwined, so that when you need to make a change somewhere, it does not affect every other part of the system, because you get so bogged down and it does not support scalability, right? So those are some of the things. And then build things like monitoring services.
Okay.
Things to monitor your performance, the performance of the app, the usage, user behavior, error monitoring, and all of those things. So all of those things helps you to be proactive, to understand the patterns, the usage pattern of your app, and how your app respond under different scenarios, right? So it makes you to be preemptive in your approach, so that when you notice an issue, notice a problem, you fix it on time before it gets escalated, right? So, but let's remember that scalability is not a one-off thing. It is something like an ongoing process.
Okay.
So something like a process that's continuously ongoing, that needs to evolve, that you need to improve in. You look at the pain area, you look at the areas where you need to even improve more, depending on need, users, and everything. So it's an ongoing process. But however, the foundation will need to be there for you to be able to successfully scale and scale easily.
Awesome. Wow. Amazing stuff you're sharing, Osagie. So in my mind, I'm just thinking like, okay, I would ask you to share an example, but in my mind, I'm thinking, okay, it's more of like as far as your eyes can see kind of situation, as far as you can envision. So you have to be able to build and like to be able to build that foundation right from the start.
Exactly.
So imagine where, like you gave the example of maybe ChatGPT, I didn't see it coming. Like the surge was over my budgeting, was over the capacity that I actually built for. Have you ever had such case studies before where there was literally like a crippling of maybe a business or maybe an application and the likes due to scalability issues? Have you personally had that kind of issue?
Of course.
You said of course, like it's normal.
Of course. I've seen apps that were not truly built to scale.
Right?
And
you were involved in the building of the process.
Yes, part of the process. I came in somewhere in the process, but those apps were already live. And later, because of usage, we have scalability issues. So, but when those things happen, there are actions you can take to mitigate for the meantime, while you reiterate and rebuild some parts of the applications. Right, there are things you can do. For instance, if it's a monolithic app, that is not a that does not have.
I was just going to ask you what is monolithic. Wow, I'm glad you explained.
Yes, app that does not take after the microservice architectural pattern. Or it's not a distributed app where you have different services. Different services, right, that cater for different needs, all of them, different services, all as part of the application, right? But it's just one application. It's not divided into separate services, right? It's just one app. And one of the services in that app is failing, or there's a need to scale, right, based on usage. So I've seen stuff like that, and one of the things we did to mitigate that for the meantime is introducing things like load balancers. Yes, introducing things like load balancer. Right. So a load balancer is like a service that distributes load across servers. So what you can do is to deploy those apps on different servers.
Okay.
The load balancer will now distribute the user requests that are coming to that app to each of the servers, depending on the algorithm that's chosen for the load balancer. Right. So that all the user requests and the load will not be coming into one server. But that's also an example of scaling out.
Okay.
Right. Okay. So you could also implement those, right? Although making things even more modular is a better approach, but then you may not have the time to do that.
Okay.
So those are some of the things you can do. Then on the data end, how does your app process data, retrieve data? You may need to optimize those processes. Okay. And the kind of storage you use. If, for instance, it's an SQL database, you need to know the type, right? So let me just give one instance, right? In one of our applications that I've worked on, right, in the past, we discovered that the storage that was being used, the type of storage, the type of SQL, or the particular edition or version was the issue. So we had to change to a better one to accommodate the rise in usage for users. So there are various things that you could do. You could look at how your app handles data. You could look at sort of scaling horizontally. So some of those things can mitigate issues with scalability on an app that's problematic.
Awesome. Yeah. It's good to know that there is like a disaster recovery mechanism in that sense, such that if peradventure, I envision,
there's a fallback plan.
Exactly. This has been an awesome conversation, truly. Osagie, you have been dishing out of the wealth of knowledge. So this is my last question, basically, before we wrap up on this episode of the podcast. So what do you think, or rather, how do you think emerging technologies like AI and machine learning will impact scalability?
Yes, emerging technologies, as you say, AI, machine learning. So they will ultimately have great impact on scalability. For instance, automated scaling, right? So when you deploy them, they will be able to know when to scale.
By themselves. Automatically.
Exactly.
Interesting.
When do I add more servers? When do I add more nodes? Or when do I... So it's either they can take the actions or they will
make the recommendation.
Exactly. Okay. So they could also be built to make the recommendation based on intelligence and several things that they have learned along the way. Right, so they could help in automated scaling. They could also help in things like predicting maintenance. When certain maintenance is due. For instance, do you need to do some archiving? When is archiving of a database due?
Okay.
When are certain backups due? Right, so they will be able to help with all of those, when to scale up, when to scale down, when to do preemptive maintenance, and then even self-healing exercises. Right.
Okay.
So self-healing exercises. For instance, when a service is down, they'll be able to automatically know when to restart the service, know when to reroute traffic. Right. Some of those things, I see machine learning and AI being important, are very useful in those aspects, some of those aspects.
Amazing. Wow, thank you so much, Osagie. This has been a very, very insightful conversation. Thank you so much. And I look forward to bringing you on another episode of the podcast, maybe most likely with another engineering manager, and you guys are going to just trash out this topic of scalability. I see that is something that you're really passionate about. Thank you everyone for joining in on this episode of the podcast. Feel free to drop your comments, questions you might even have for Osagie, and we will be sure to respond to them in the comment section. Thank you so much for your time, and we look forward to seeing you on another edition of the Qorent-Xperts podcast. Till I come your way again, keep being courageous.